Okay, good morning පුතේ. අපි අනිත් අය යනකම් පොඩ්ඩක් ඉමු කියලා තුමන් 8:15 පටන් ගන්නවා කිව්වේ. හොඳයි. එතකන් ඕගොල්ලන්ට පුංචි හිතන්න දෙයක් දෙන්න හිතුවා. මම මේක අර 24 ක්ලාස් එකේ දාපු එකක් 24 ළමයිට විශේෂ මේ දීපුංචි එක්සර්සයිස් එකක්. හැබැයි මේ ඊට පස්සේ මම දැක්කා අර ඔයගොල්ලන් අර මේ ඔරල් පේපර් එකෙත් මේ ක්වෙස්චන් එක වගේ එකක් අහලා තිබ්බා මේ ගිය අවුරුද්දේ. මොකද්ද v equal f lambda equation එක. v equal f lambda equation එක ඔයගොල්ලන් මේක ඕනෙම වේව් එකකට දාන්න පුළුවන් කියලා. හරිද? ඕනෙම වේව් එකකට දාන්න පුළුවන්. හැබැයි දැන් මේක අනුව frequency කියන එක that might be depend on මේ velocity and lambda no according to this equation, but frequency doesn't depend on those factors. Okay, and this equation can be used for any wave, any kind of wave. Okay, my question is, what is the reason for that? මොකක්ද ඒකට හේතුව? කොහොමද ඒක අපි කියන්නේ? කොහොමද ඒක හිතන්නේ? පොඩ්ඩක් තනියම හිතන්න. හරිද? තනියම හිතන්න කොහොමද v equal f lambda කියන equation එක කොහොමද මේ හැම වේව් එකකටම දාන්න පුළුවන්? හරිද? මුලින් හිතන්න. දැන් ඒක මේ කොහෙන්වත් පොතකින්වත් බලන්න එහෙම බලන්න එපා. මුලින් හිතන්න කොහොමද v equal f lambda කියන equation එක කොහොමද හැම වේව් එකකටම මේක හරියන්නේ? මොකද waves වල ගොඩක් තියෙනවානේ පුතේ. sound waves තියෙනවා, light waves තියෙනවා, ඊළඟට electromagnetic waves තියෙනවා. එක මේ waves types තියෙනවා. මොකද හැම wave type එකකටම මේක හරියි. හරිද? එහෙමනම් කොහොමද ඒක උනේ? හරි. මේක පොඩ්ඩක් ඔයගොල්ලෝ තව ඉස්සරහට යද්දී ඔයගොල්ලෝ කිව්වේ අහුවේ. ඒ වුණාට මම කැමති පුළුවන් නම් හිතන්න. තනියෙන් හිතන්න. හොඳයි. මම හිතන්නේ අපිට ක්ලාස් එක පටන් ගන්න පුළුවන් වේද? Okay. Shall we start? Okay. Up to last week, we have done addition of two vectors. And application of the resultant vector. Okay. And we have completed those parts. Now, today, we are going to do the resolving or resolution of vector. That means, now we are going to resolve a vector into two components. Okay. Write a topic. Resolving vector. Resolving a vector into two components. Two perpendicular components. Okay. Two perpendicular components. This is the topic. Now we are going to resolve a vector into two perpendicular components. I will explain what is the meaning of this. Okay. Write the topic. Resolving a vector into two perpendicular components. Okay. I will erase this, okay? I will erase this. Okay. Suppose there is object and there are two forces acting on this object. Suppose there are two forces acting on this object. One is x and another one is y. And the resultant of those two vectors is r. Suppose the resultant of those two vectors is r. That means the resultant of those two vectors is r. My question is, what is the meaning of resultant force? Or what is the meaning of resultant of these two vectors? Tell me anyone. What is the meaning of? Okay, I'm recording. Okay. Suppose there are two vectors acting on this object, okay, and the resultant of those two vectors is R. My question is, so what is the meaning of the resultant vector? Can anyone tell me what is the meaning of the resultant vector? We have a lot of questions may find the resultant vector, and I have given the meaning of the resultant vector too. Okay. Now I am asking the same question. What is the meaning of the resultant vector of two vectors?
The vector that is equal to the sum of the two vectors.
Yeah, sum means the vector sum of two vectors. Yes. Yeah, that can be okay. But the thing is, the most important thing is, we can replace these two vectors by from this resultant vector. That means the resultant vector is the vector that gives the same result. That gives the same result that of these two vectors. No? So if I replace these two vectors from the resultant vector, the system doesn't change. No, it remains unchanged. Do you understand that one? So resultant vector is the vector that gives the same result that of these two vectors. Okay, it will give the same result. It will give the same result. So how to find the resultant vector? How to find the resultant? The way of finding resultant vector is, we have to get the vector sum of these two vectors. If I get the vector sum of these two vectors, I will have the resultant vector. That is the way of finding resultant vector. So my question was, I was not asking about the way of finding resultant vector. My question was, what is the meaning of resultant vector? The meaning of resultant vector is, Buddha, we can replace a vector system by resultant vector. The resultant vector is a vector that gives the same result that of these two vectors. Did you understand that part? So I can replace these two vectors from the resultant vector because it gives the same. I need response from everyone. Do you understand this part? This is the meaning of resultant vector. Thank you. Others? If anyone may, okay. Okay, please give the responses from everyone. Then, okay. According to that definition, according to that meaning, I can replace these two vectors by the resultant vector. Okay, from the resultant vector. That means if I use these two vectors on the system, and instead of these two vectors, if I use the resultant vector on the system, the result won't be changed. Result won't be changed. It will remains unchanged. So these two are two identical vector systems. These two are two identical vector systems. Okay, this is a vector system. This is a single vector, but these two are two identical vector systems. Okay, so if I apply two vectors on the system, and if I apply one vector, the resultant vector on this system, they will give the same result. Okay, they will give the same results. Therefore, these two are two identical vector systems. Therefore, I can put the equal mark. I can put the equal mark on this, in between these two. Those are two equal vector system, because both systems give the same result. In our previous lesson, we have found the resultant vector of vector system, or two vectors, actually two vectors. We have found the resultant of two vectors, no? Now I'm going to do the reverse work. So if you are given one vector, then I can replace these one vector from two vectors. No, the same thing can be done. So if you are given one vector, here, I can replace this vector from two vectors. No, from two vectors. The requirement is these two, the vector sum of these two vectors should be equal to this. That means the resultant force of these two vectors. If the resultant force of those two vectors is equal to R, then I can replace R by these two vectors. Did you understand that? I can do the same thing, no? In the first case, I have found the resultant vector. That is the single vector that can replace these two vector systems. Now I am going to do the reverse work. If I am given the one vector, then I can replace this one vector using two vector system. The requirement is these two, the resultant force of these two vectors should be equal to R. Then I can replace R from these two vectors. Did you understand? Did you get my point? Did you get my point? Thank you. Okay. So this process is called as resolution or resolving of vector. So these two vectors are called as the resolution components of this vector. Okay, so this process is called as resolution of vector or resolving of vector. Okay. Draw this image, draw this figure, the first one. Draw the first figure under the topic. Draw the first figure. Topic puta resolving a vector into two perpendicular components. Topic, those who are coming lately, resolving a vector into two perpendicular components. Resolving a vector into two perpendicular components. This is the topic. Draw this image under this topic. Draw the first image, okay? Don't draw the second image. Okay, right under this image. Suppose capital R is the resultant of X and Y. Suppose capital R is the resultant of X and Y. The resultant vector is the vector, the resultant vector is the vector that gives the same result, that of X and Y. Therefore, X and Y vectors can be replaced by R. Everyone, please look at the board. Put simple A to this figure and this is simple B. Okay, put these two letters. This is simple A and this is simple B. Okay, simple A and simple B. Okay, then write in a new paragraph. Therefore, the system A, A means this one, okay? Simple A. The system A and the system B are two identical vector systems. According to that argument, two vectors can be replaced by a single vector. Can be replaced by a single vector. On the other hand, that single vector can be replaced by two vectors. That process is called as resolving of a vector. Resolving of a vector. Okay. Okay, you can draw this figure. After writing that sentence, you can draw this figure under that paragraph. Okay. This is R. Now we are going to resolve this R into two vectors. It is called as resolving of R into two vectors. Okay. Right under this figure, When resolving a vector into two vector components, when resolving a vector into two vector components, there is a mandatory requirement to be fulfilled. That is yes. I will explain that. Okay, I will explain that because it is not a mandatory requirement, but normally the resultant force is normally it is towards the higher force. I will explain that one. Okay, I will explain that one when we are doing the questions on resultant force, especially in MCQ questions. Normally, the resultant vector normally it is very near to the higher vector. Okay. You can okay. That will be a question. Everyone, ask me. Good question here. Okay. This is not regarding the resultant force. Okay. There's a question. Suppose there are two vectors here. There are two arbitrary vectors, P and Q. You know the resultant force of these P and Q is represented by R. Normally, this R, the resultant force, normally it is close to the higher force among these two forces. Okay. Force means vector. Okay. Force means vector. We have force here. Okay. Force means vector, any vector. Okay. Suppose this vector, this is 100 Newton, and suppose this is a 10 Newton. You can see 100 Newtons is larger than 10 Newton. That means this resultant force normally it will be close to P. It will be close to P than Q. Normally, the resultant force is closer to the large force than the small force. Okay. When you are drawing this kind of figure, it is good to good to draw this something like this, but it is not a requirement. Okay. My question is how to prove that one? Okay. I need your answers. Okay. You can do it as a homework and send the answers to me. Okay. My question is, suppose there are two forces acting on an object, and normally the resultant force is closer to the larger force. among these two forces. Okay. My question is, prove that thing. Prove that thing. Okay. You have to prove that thing. Okay. I think you can understand my question. Do you know my question is? No, not now. Not now. As a homework. Okay. As a homework. Not now. My question is, okay. Give me the answer. Give me the answer as a proof. With proof. Okay. With proof. Give me the answer. You can do it in a rough sheet and send the photo. Okay. Do it as a homework. Okay. Do it as a homework. Don't put these numbers. Don't put these numbers. You can if you want to use these numbers, you can use. Okay. That is not issue. Okay. But you have to prove that thing. You have to prove that thing. I will explain that thing when we are doing the MCQ questions. But before that, you have to prove that thing. Okay. Okay. What was my last sentence? Can anyone tell me? What was my last sentence? Okay. There is a mandatory requirement to be fulfilled, no? Okay. That is the resultant of the resultant vector of the two vector components. The two vector components should be equal to the single vector. Should be equal to the single vector. Okay. Look at the board. Suppose there is a vector here. There is a vector here. Suppose this is R and the angle with the horizontal is theta. Angle with the horizontal is theta. The vector is R. Now, normally, actually, we can replace this R by any two vectors. Any two vectors acting on a certain directions. But in physics syllabus, in LL physics syllabus, we have to study about two perpendicular components only. Two perpendicular components only, because actually, if we want to resolve this vector into some, we can resolve this vector into certain directions. But if we want to find those components, we have to apply some trigonometric rules. Trigonometric, actually, it is a mathematical operation. It is a mathematical operation. So we are not going to do that much of things. So our syllabus is limited to finding two perpendicular components only. Two perpendicular components only. Okay. Therefore, Now we are going to replace this vector by two perpendicular vector components only. Two perpendicular vector components. Okay. Okay. Suppose there is a vector R acting on an object, and this R creates a theta angle with horizontal. This is the original force. Now I'm going to resolve this force into two perpendicular components acting at the same point. Okay. Suppose this is the point A. Now I am going to resolve this force into two perpendicular components acting at the same point. Therefore, now I have to replace this R by two perpendicular components. Two perpendicular components acting at the same point. That means this point. Suppose I am going to resolve this force into the horizontal direction and the vertical direction. If I resolve this force into horizontal direction and perpendicular direction, that means the angle between the horizontal and vertical is 90 degrees. Therefore, they will act as two perpendicular components. Therefore, now I am going to resolve this force in horizontal and vertical directions. How to do this? Suppose these two forces are P and Q. Suppose these two forces are P and Q. Now I am going to replace R by P and Q. How to do that? Suppose this angle is theta. That means, look at this. That means the resultant force of P and Q, is equal to R, no? That is the argument. The resultant force of P and Q is equal to R. That is my argument. Okay. Now I am going to resolve this force into two perpendicular components, P and Q. So our mandatory requirement is the resultant force of P and Q. Yes. Okay. Okay. Shall we do that? Now, what is my objective? Yeah, I will explain that one. Okay. Then our requirement is my objective is I'm going to resolve this force into two perpendicular components, P and Q. Therefore, my mandatory requirement is the resultant of P and Q should be equal to R. Now you can draw these two forces acting at the same point. This is P, sorry, this is Q, this is R. So this is P, and this point is A. The resultant of these two forces creates theta angle with force P. Okay. If you want to find the resultant force of P and Q, you have to complete the vector paradigm. No, you have to complete the vector paradigm. Now I am going to complete that vector paradigm. If I complete this vector paradigm, as this is 90 angle, this one should be equal to 90 degree too. Suppose this is A, B, C, D. This one is R. This one is R. Okay. We can complete this vector parallelogram, no? Did you understand this one? Did you understand this argument? Okay. What is my requirement? Again. I will explain again. My objective is I'm going to resolve this force into two perpendicular components. Therefore, my mandatory requirement is the resultant of P and Q should be equal to R. Now I have drawn the two forces P and Q. The resultant of P and Q can be found using the vector parallelogram theorem. Therefore, I have completed that vector parallelogram A, B, C, and D. According to vector parallelogram theorem, the resultant force is represented by this AC diagonal. Okay, that is R. Okay, this is my construction. Now I am going to find the magnitude of P and magnitude of Q. Magnitude of P and magnitude of Q. Okay, how to find those magnitudes? What are my non-factors? What are my non-factors? What are my non-factors? Actually, I know the value of R because this is a single force now. So this is the given value. Okay? This is the given value. Given value is the resultant force R. It is given. And the theta angle, it is also given. So those are the two given factors. Okay. So I have to find the magnitude of P and magnitude of Q with respect to using these two given values. How to find that one? Tell me a method. How to find the magnitude of P and Q? Tell me a method. Yes, very good. You can see ABC. ABC is a right angle triangle. Yes. Not Pythagoras theorem. Okay. ABC is a right angle triangle. If you want to use Pythagoras theorem, you have to know at least two sides. Now, we are given only one side, that is hypotenuse and the angle. Therefore, I cannot use Pythagoras theorem. But I can use the definition of sine cos tan. Because I know this value, this angle, and the hypotenuse. Suppose this ABC is a right angle triangle of the you know ABCD is a parallelogram. Therefore, AD should be equal to BC. Therefore, this side is equal to Q. No? This side is AB side is equal to P. P means magnitude of P. This is magnitude of Q. Okay, magnitude. Now I know the magnitude of AC and this value theta. I know I know the hypotenuse of ABC triangle and this angle. Okay, I can use ABC triangle. Using ABC triangle, look at this. I know the hypotenuse. I know this angle. If I want to find Q, what should I do? I know the hypotenuse. I know this angle. I need to find Q. So what should I do? This is trigonometry. That's why yes, very good. මේ questions හැදුවේ එකයි මං කලින්. Look at this. Theta is the opposite side to theta is the opposite. Q is the opposite side to theta angle, and R is the hypotenuse. I know this value and hypotenuse need to find opposite angle. Therefore, I can use sine. I can use sine values. So if I use sine theta is equal to opposite side over the hypotenuse. Opposite side means BC over hypotenuse AC. You know, sine theta, BC means Q, AC means R. AC means R. Therefore, Q is equal R sine theta. Q is equal R sine theta. Okay. The second thing, P. I can find P. How to find P? P is the adjacent side to this angle. Therefore, the given value are this hypotenuse and this angle, and I need to find the adjacent side. Adjacent side, hypotenuse angle. Adjacent side, hypotenuse angle. What is the trigonometric function? It is cos here. It is cos. So cos theta is equal adjacent side AB over the hypotenuse AC. Therefore, I can replace the values. AB means P. This is R. This is R. Therefore, I can write R is, sorry, P. P is equal R cos theta. P is equal R cos theta. From here, you can go to here. R cos theta. Therefore, I can resolve these two components. Suppose this is R. Suppose this is R, and it creates theta angle with the horizontal. Theta angle with the horizontal. Then the components into horizontal. Components into this angle, into this angle side is equal to R cos theta. Component into the other side is R sin theta. මේ theta angle එක තියෙන පැත්තට හැම වෙලේම R cos theta එන්නේ. අනිත් පැත්තට R sin theta. Okay. Okay. අනික හොඳට මතක තියාගන්න ඕගොල්ලෝ මේක අඳිනකොට මේ බලන්න. මේක වෙට්ට paragram එකනේ පුතේ. මේක වෙට්ට paragram එක. ඒක නිසා මතක තියාගන්න මෙයාගේ මේ end points දෙක මේක අපි paragram එක complete කරොත් එහෙම එන විදිහට අඳින්න ඕනි. ඒ කියන්නේ මෙහෙම අඳින්න බෑ. නේ? මෙහෙම අඳින්න බෑනේ. R එක අම්බානක ලොකුයි මේ දෙක පොඩි. එහෙම අඳින්න බෑ. නේ? මෙහෙම. ඔබ කරන් එන්නේ නැහනේ. මේක හරියට මේ perpendicular යන විදිහට මෙන්න මෙතනට එන්න ඕනේ. ඒ නිසා මෙන්න මේ මට්ටමට අඳින්න. roughly හිතන්න. roughly විතරයි හිතන්න. නැතුව මේ ඉරි ගහලා අඳින්න ඕනේ නැහැ. roughly හිතලා. හරි. මේක ගොඩක් දික් කරන්නත් එපා. ඒ වගේම දික් කරන්නත් එපා. මේක මෙහෙම දික් කරන්න එපා. එතකොට ආයෙසරයක් එළියනේ. හරිද? එහෙම කරන්නත් එපා ගානට. මෙතනින් perpendicular එකක් මෙතන ගහුවාන් එන තැනට එන විදිහට අඳින්න. Okay. මෙතන පොඩි topic එකක් දාගන්න. Topic එක finding the magnitude of perpendicular components. Finding the magnitude of perpendicular components කියලා මේක දාගන්න. මේක හඳගන්න. Yes, you can use. You can use simultan very sharp finding one side, but it is something long method, no? Once you find the one side, other side also find. You can find two sides at one time. දැන් use කරන්න පුළුවන්. දැන් use කරන එක පළවෙනි දේ එකක් risky. මොකද ඔයා එක side එකක් හොයනකොට මොකක් හරි වෙලා වැරදුනොත් එහෙම ඊළඟ side එකත් වරදිනවා. හිතන්නකෝ ආ sin හරි cos හරි ගන්නකොට වරදගත්තා කියලා. එතකොට ඊළඟ side එකත් ඔයා වරද ගන්න ඕන පුතේ. හරි. Okay. Shall I erase this? Shall I erase this? Okay. Others? Have you completed writing? No, I'm still writing.
Still writing, sir.
Okay, Putih, thank you. Shall I erase? Shall I erase? Okay. Okay. Normally, look at this. You can remember this one very easily. Okay, look at this. Suppose this angle is theta. Suppose this angle is theta. If this angle is theta, therefore component into this side, into this theta side, component into this theta side, always a cos value. R cos theta. R cos theta. Because this side is the adjacent side to this angle. As this side is the adjacent side to the angle, this adjacent side always cos value. It has always cos value. Therefore, this component, the adjacent component to this angle, should be a cos theta. Should be a cos value. Should be a cos value. Therefore, this one is r cos theta because it is the adjacent side. And this one is the opposite side. This side, no? Therefore, this is the opposite side. Therefore, this one, this component is equal to r sine theta. This component is equal to r sine theta. Okay. Okay. Look at this again. Look at this again. Suppose you are given a vector to resolve into two components. So the resolving component into the adjacent side to this angle always cos theta, always a cos theta. The other component is always a sin theta. Okay, you can remember like this. This is adjacent side to theta. This is adjacent side to theta. This is opposite side. Opposite side to theta. This is opposite side to theta. This is adjacent side. This is adjacent side to theta. Therefore, as this is the adjacent side, this always a cos value. This one always a sin value. Therefore, okay. Do you get my point? තේරුණාද? ඔයගොල්ලන්ට මේ විදිහට මතක තියාගන්න පුළුවන්. හරි. Okay. Draw this image. Draw this figure. Adjacent side always a theta. Opposite side always a sin value. Adjacent side always a cos value. It always a cos value. ඒක මෙහෙම දාගන්න. It always a cos value of theta. Cos value of theta. Okay. Cos value of theta. This one, it always a sin value of theta. Okay. Sin value of theta. Okay. නැත්නම් මෙතන එක අරගෙන මේ 90 minus theta අරගෙන 90 minus theta වලින් කිව්වොත් එහෙම මොකක් වෙනස් වෙනවද? එහෙම නේ මං කියන්නේ. theta වල sin value එකක් මේක. මේ theta වල cos value මොනේ? එහෙමයි. පටලවා ගන්න එපා. Okay. Look at this. Everyone, look at the board. Look at this. This is a note. Everyone, look at the board. I need your attention. Everyone. Suppose there are two perpendicular forces. Suppose there are two perpendicular forces. One is r cos theta. Other one is r sin theta. Suppose there are two perpendicular forces, r cos theta and r sin theta. So if there are two perpendicular forces, how to find the resultant force? How to find the resultant force of this one? Suppose the resultant force is x. How to find the resultant force of this one? I think we have done this under the special categories of find the resultant force. X squared is equal r cos theta squared plus r sin theta squared. No? This is the way of finding resultant force of two perpendicular forces. Suppose this is P, this is Q. So x squared is equal P squared plus Q squared. Ne? Because there is no 2pq cos theta. There is no 2pq cos theta because this angle is 90. This angle is 90 and cos 90 is 0. Cos 90 is 0. Therefore, there are only two terms. One is P squared, other one is Q squared. Okay. Therefore, suppose the resultant force of these two forces is equal to x. Therefore, x squared is equal to square of this value plus square of this value. Do you understand that thing? I got responses then. Okay. Okay. I can simplify this one. S squared is equal, this one is equal to r squared cos squared theta. R squared cos squared theta plus this one is r squared sin squared theta. R squared sin squared theta. Okay. Look at these two terms. Look at these two terms. Look at this. R squared is common factor for these two terms. Therefore, I can take it out. Okay. So, if I take it out, the remaining is cos squared theta plus sin squared theta. Cos squared theta plus sin squared theta. How much the value of this one? How much the value of this one? Cos squared theta plus sin squared theta? Yes, very good. It is equal to 1. This is equal to 1. This is equal to 1. And ඒකයි trigonometric කෝණ කියන්නේ. This is equal to 1. This is equal to 1. Therefore, x squared is equal to r squared. That means x equal to r. X equal to r. Now you can clearly understand the resultant of these two forces. The resultant of these two forces should be the previous single force. That means r. That is equal to r. Okay. තේරුණාද එක? Okay. Once you draw this figure, you can write this as a note. Write this as a note. Okay. Shall I erase this one? Shall I erase? Yes. You can use my wet addition theorem. No? Addition may you can use principle of wet addition. No? You can use that one. Without Pythagoras theorem, you can use with addition also. Look at this. This is x. This is x. This one is very good question. R sin theta. This one is R cos theta. This one is R cos theta. Okay. Therefore, I can complete vector paradigm. I can complete the vector paradigm. If I complete the vector paradigm, this will be something like this. Suppose this is A, B, C. Now you know this side and this side are equal to each other. Therefore, these two vectors are two equal vectors. R sin theta. Look at this. This one. These two vectors. So if I use the vector addition theorem, look at this. This is the starting point and this is the end point of the first vector. And this is the starting point of the second vector. Therefore, the starting point of the second vector and the end point of the first vector are coincide to each other. No? Are coincide. And AC is the addition of these two vectors. No? I can use the vector triangle method. AB plus BC. AB plus BC is equal to AC. No? So if I use vector triangle method or vector addition method, both are same. If I use vector triangle method to ABC triangle, look at this, AB plus BC. AB vector plus BC vector. AB vector plus BC vector should be equal to AC vector. Look at this. This is the end point, this is the starting point. Both are same. That is the way of writing vector triangle. AB plus BC. AB, this is the end point. This should be equal to the starting point second vector. This is the end point of the first vector. This should be equal to the starting point of the second vector. If so, this is a vector triangle. Therefore, the resultant is AC, is starting to end point. AC. Therefore, AC vector. You know this one. AB vector is R cos theta. BC vector is R sin theta. Is equal. AC vector is X. Okay. This is X. This is a vector addition principle. Okay. Vector addition principle. Okay. Then we can say, don't write this one. සමහර විතන්න පුළුවන් r cos theta sin theta එකතු කරාට පස්සේ x කියලා. ඒක නෙවෙයි වෙන්නේ. අතන මේකේ මොකද්ද? වෙක්ටර් addition එක ගන්නෙ. ඒ නිසා මෙතනින් නවත්තන්න. AB plus BC is equal to AC. AB plus BC means AB vector is this one, BC vector is this one. Therefore, AC vector is X. Then we can say the resultant vector of R cos theta and R sin theta is equal to X. Okay. Yes. Yes. We can prove that. Okay. Okay. Now we can go for the questions. There are two type of questions. There are two type of questions in vector resolution method, and we have to have those two knowledge. First one is we have to resolve a single vector. We have to resolve in a single vector. Resolve in a single vector. Other one is resolving a vector system. Okay. There are two types of questions. Resolve in a single vector and resolve in a vector system. Actually, resolution of a vector, that means resolving a vector, you are not given questions in exam under the resolving a vector. This is an application. This is an application that can be used for many cases, resolving of vector. Therefore, this is a very important application that can be applied in so many applications. Okay. Therefore, you are not going to ask to resolve a vector in your LL exams, but that knowledge is definitely, you need that knowledge for many questions in LL exams. Okay. LL exam එකේ තියෙන ගොඩක් questions වලට ඔයාලට මේක ඕනි වෙනවා, especially in mechanics. But you are not given a direct question in vector resolving method. Okay. Okay. Right under that note, resolving of a vector. Resolving of a vector can be studied under the following cases.
Sir, can you repeat it again?
Resolving of a vector can be studied under the following cases. First one is resolving a single vector. Second one is resolving a vector system. Okay. Shall we do some questions? This is the questions on magnitude. Write a topic. Questions on resolving of vector. Questions on resolving of vectors. Write this topic. Then you can use this. You can write this topic. After writing this topic, question number 1. Do the first 3 questions. Do the first 3 questions. Don't do 4th, 5th after this one. Do the first 3 questions. Okay. Shall we do? Okay. Give me the answers. First one. So what is the horizontal component? X. What is the horizontal component of this force? X. You have to write the direction also. You have to write the direction also. So what is the horizontal component of this force? Give me the answers. Go. Answers to that. So what is the horizontal component? Yes, very good. Man, this is 40 cos 60. Ne? Look at this. Horizontal component. The horizontal component is the adjacent component to 60. Ne? Adjacent component of the 60. Otherwise, other thing, horizontal component is the component into this angle. Therefore, it should be a cos value. It should be a cos value. Therefore, 40 cos 60. Cos 60 is half. Half means this is equal to 20 Newton. This is equal to 20 Newton. This is in this direction. Therefore, you have to draw the direction also. Then, the y direction, sorry, y component. Y component. Normally write as this way, y component. Normally, in this case, y component is in the upper side, upper direction. Therefore, y component is equal to 40 sin 60. 40 sin 60. So that is equal to 20 root 3 Newton, because sin 60 is root 3 over 2. Don't write that one. You can divide 40 by 2. It is 20. 20 into root 3. Write it as 1. As a 1. Okay. මේ උත්තර ආවද? මේ answers ආවද? මේ answers ආවද ඔයගලන්ට? Give me a response. Okay. එක්කෙනාට දාවේ? Okay, okay. Okay.
So isn't it necessary to draw the parallelogram?
No. It is not necessary. But you have to draw this force. Okay. You have to draw this force. Then you can use these 2 equations. R cos theta and R sin theta. R cos theta and R sin theta. The component into this angle is equal to R cos theta. R cos this angle. other one is r sin theta. Because this is the adjacent side with respect to this angle. No? This is the adjacent side with respect to this angle. Therefore, this one is r cos 60. Other one is r sin theta 60. You can use these equations directly. Then, okay, if you resolve this 50 root 3, 50 times root 3 into x side, x direction, it will be in right hand side, into right hand side. If you resolve it into y direction, it will be directed to the upper direction. Therefore, x component into this direction is equal 50 root 2, 50 root 2 cos o sine, cos o sine, cos o sine. 50 root 2 cos o sine, cos, because this is the adjacent side with respect to theta, no? This is the adjacent side with respect to theta. As this is the adjacent side, this is cos 30. Cos 30. Cos 30 is equal to root 3 over 2. Root 3 over 2. Therefore, this one is equal to 55 root 6 Newton. තේරුණේ? කොහොමද එකපාර ගත්තේ? බලන්න. Okay. දැන් මම අර algebra කතා කරනකොට මම කිව්වා algebra කතා කරනකොට මම කිව්වා කොහොමද mind එක use කරලා වැඩේ කරන්න කියලා. දැන් ඕගොල්ලෝ ඒවා practice කරන්න ඕනි. ඕගොල්ලෝ ඒවා practice කරනවා. දැන් single medium කට්ටිය දැන් මම practice කරලා දැන් හොඳ තත්ත්වෙ ඉන්නවා. දැන් සාමාන්‍යයෙන් ඒගොල්ලෝ steps දෙකෙන් වගේ ගන්නවා. හරිද? ගොඩක් කට්ටිය. ඒ නිසා හැම වෙලේම practice කරන්න ඕනි මම කිව්ව විදිය. දැන් ඊළඟට අපි ආයෙත් කතා කරන algebra questions එහෙම මතක තියාගන්න ඒවා use කරන්න ඕනි ඕගොල්ලන්ගේ mindset එක හදාගන්න especially bio කරන කට්ටිය පුතේ maths කරන කට්ටියට බය වෙන්න දෙයක් නැහැ බය වෙන්න දෙයක් නැහැ නේ උනුත් එක practice කරන්න ඕනි practice කරලා නැත්නම් කරන්න බෑ හරිද නමුත් මම හැම වෙලෙම කියන්නේ දැන් මම මෙතන 25 times root 6 ගත්තා one time ඒ වගේ දේවල් one time ගන්න පුළුවන් වෙනවා හරිද මොකද මේක තව steps ටිකකින් යනවා කියලා කියන්නේ තේරුමක් නැහැ හරිද මොකද මම කියන්නේ මේකයි මම හොඳට ආයෙත් අහගන්න අපි මේක හැම වෙලෙම කරන්න මයින්ඩ් ගේම් එකක්. මම ආයි කියන්න අවශ්‍ය නිසා මයින්ඩ් ගේම් එකක් නම් කරන්නේ අනිවාර්යෙන් ඕගොල්ලන්ට මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිසස් ඕනිමයි. මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිසස් ඕනිමයි. මැත්ස් කරන කට්ටියට මම බය වෙන දෙයක් එපා කියලා කියන්නේ මොකද මැත්ස් වලදී පුතේ අනිවාර්යෙන් මැත්ස් නිසා මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිසස් එනවා ඒගොල්ලන්ට. මොකද මැත්ස් ගණනක් කරනවා කියලා කියන්නේ අනිවාර්යෙන් ලොයිත් හිතන්න තියෙනවා. ඒ කියන්නේ ගොඩක් කරලා හිතන්න තියෙනවා. තනි කරා මයින්ඩ් එකෙන් කරන්න තියෙනවා. මැත්ස් ගණන. ඒ නිසා අනිවාර්යෙන් ඒගොල්ලන්ට මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිස් එනවා. ඒක තමයි අර normally කතාවක් තියෙන්නේ. බයෝ කරන කට්ටියට ෆිසික්ස් අමාරුයි, මැත්ස් කරන කට්ටියට ෆිසික්ස් ලේසි කියලා. හරිද? ඒ ලේසි වෙන්න එකම හේතුව මැත්ස් කරන කට්ටියට ෆිසික්ස් මැත්ස් වල උගන්වන නිසා නෙමෙයි. එහෙම දෙයක් වෙන්නේ නැහැ. මැකනික්ස් කියලා පොඩ්ඩක් අහුවෙලා මැකනික්ස් කියලා පොඩ්ඩක් අහුවුණාට පුතේ සිලබස් එකෙන් ඉතුරු ඔක්කොම ටික තියෙනවා අනිත් ඒවානේ. හරිද? නමුත් මැත්ස් කරන කට්ටියට ෆිසික්ස් ලේසි හේතුව එකම හේතුව මැත්ස් කරන කට්ටියට මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිසස් තියෙනවා ඒගොල්ලන්ට. හේතුව අපි මැත්ස් වල ක්වෙස්චන් එකක් කරනවා කියලා කියන්නේ ඒක අනිවාර්යෙන් තියෙනවා. අපි එහෙම කරන එකෙත් විතරයි හොඳේ. එහෙම නැති එකෙත් නෑ මම ඒක මැත්ස් කරා කියලා මැත්ස් කරන හැමෝම ෆිසික්ස් පාස් වෙනවද? නැහැනේ. හරිද? ඒක නිසා මැත්ස් කරන කෙනෙක් හරියට මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිස් කරනවා නම් හරියට මැත්ස් වල ගණන් ටික හදනවා නම් අනිවාර්යෙන් උට මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිස් එනවා. එහෙමනම් අනිවාර්යෙන් ඒගොල්ලන්ට පොඩි ඇඩ්වාන්ටේජ් එකක් එනවා. හැබැයි බයෝ කරන කට්ටියට ඔක නෑනේ. බයෝ කරන කට්ටියට ඔක නෑ කියලා කියන්නේ බයෝ කරන කට්ටිය ඕල් මැත්ස් වලින් පස්සේ මැත්ස් අහු වෙන්නේ නෑ. හරිද? ඒකයි මම අර බේසික් මැත්ස් කෑල්ල මම කරන්නෙත් ඒකයි. හොඳට මතක තියාගන්න. බයෝ කරන කට්ටිය හිතලම මේ දේ කරන්න ඕනේ. හිතලම මේ දේ කරන්න ඕනේ කියලා කියන්නේ ස්ටෙප්ස් 3කින් හදන්න ඕනේ දේ බලන්න ස්ටෙප් එකකින් කරන්න. ස්ටෙප් 4-5ක් යන දේ බලන්න ස්ටෙප්ස් දෙකකින් දෙකකට වඩා වැඩි දාන්න තු කරන්න. ඒක හිතලම කරන්න ඕනේ බයෝ කරන කට්ටිය. හිතලම හදන්න ඕනේ හිතෙන්. ඔයාගේ මයින්ඩ් එක යූස් කරලා මයින්ඩ් එකෙන්ම හදන්න හිතලම. මම ඔක මැත්ස් කරන කට්ටියට ඒක කරන්න ඕනේ. normally මැත්ස් කරන කට්ටිය කරනවා. මොකද ඒගොල්ලන්ට ඒක කරන්න වෙනවා මැත්ස් වලදී. එහෙම නැත්නම් මැත්ස් ගණනක් හදන්න බෑ. මැත්ස් වල තියෙන ගණන් වල හැටියට මැත්ස් ගණනක් හදන්න බෑ. හරිද? ඒ නිසා මැත්ස් හරියට කරන මිනිස්සෙක් ඒක ඔටෝමැටිකලි හැදිලා තියෙනවා. හරිද? හැබැයි බයෝ කොච්චර හරියට කරත් ෆිසික්ස් සමානට හැදෙන්න නැති වෙන්න පුළුවන් මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිසස් නැත්තම්. ඒ නිසා ස්පෙෂලි බයෝ කරන කට්ටිය හොඳට මතක තියාගන්න මයින්ඩ් ඉම්ප්‍රූව්මන්ට් එක්සර්සයිසස් ඕනිමයි. ඒක නිසා විශේෂයෙන් ඔය ඇල්ජිබ්‍රා ක්වෙස්චන්ස් ටික ඊළඟට ඒවා හදද්දි පුරුදු වෙන්න. ඊට පස්සේ මේවා කරනකොට මේ වගේ ක්වෙස්චන්ස් කරනකොට පුළුවන් තරම් අඩු ස්ටෙප්ස් ගන්නකින් කරන්න. පුළුවන් තරම් අඩු ස්ටෙප්ස් ගන්නකින් කරන්න. හිතෙන් ඔයාට සිම්ප්ලිෆයි කරන්න පුළුවන් තැන් හිතෙන්ම සිම්ප්ලිෆයි කරලා දාන්න. බලන්න මම මේක කරේ කොහොමද කියලා. Cos theta, cos theta is equal to root 3 over 2. Root 3 over 2. Therefore, I can divide 50 by 2. It is 25. Then there is root 2 and root 3. Those should be multiplied. Root 3 and root 2. 3 into 2, 6. So, it is inside the root symbol. Therefore, the answer is 25 root 6. 25 root 6. Look at this. 50 root 2 root 3 over 2. No? Cos 30 is root 3 over 2. Therefore, 2 to 25, 50 will be cancelled out. It is 25. This one, 2 into 3 inside the root, it is 6. Therefore, 25 root 6 is the answer. You can do it within your mind without writing additional step. Okay, it is some time saving. Then why? Why should be the sine value of this one? No, sine value of this one, 50 times root 2 sine 30. Sine 30. Sine 30 is half. Half means this one is equal to 25 times root 2 Newton. Because it is half. Half means you have to divide 25 by 2. Okay. Then, can anyone tell me how to do the third one? How to do the third one? Can anyone explain me how to do this? How to do this? Yes, very good. Very good. You can find this angle. You can find this angle, no? This angle is 30. Yeah, this angle is 30. Or otherwise, you can, yeah, this angle is 30. Suppose this one, if we want to resolve a force, everyone, I need your attention. Everyone, I need your attention. Everyone, listen to me. Suppose if you are given a vector, or if you are given a vector to resolve in two components, the first thing you have to determine the angle. The angle. If you want to resolve it in horizontal or vertical direction, the first thing you have to determine the angle between the horizontal and the given force, or angle between the vertical and the horizontal, vertical and the given force. Okay, you have to determine that thing, the angle. Actually, you are given the force, no? So if you know the force, value of force and the angle, then you can resolve the forces, resolve the force. Therefore, the first thing you have to determine the angle between the horizontal or the vertical. Both are okay. Okay. Okay, the angle between this one, angle between the horizontal and this force is equal to 30. I will do this in 2 methods. Okay. The first method, I will use this angle. I will use this angle. Look at this. This is 210. You know this one is 180. Therefore, angle between these two is 30. So I can use that angle. So if you resolve this in x and y direction, you can use this angle. if you resolve this in x direction, the resolved component into left hand side. Look at this. It is the adjacent side to 30 degree. It is the adjacent side to the 30 degree. Therefore, I can write it as 90 root 3 cos 30. 90 root 3 cos 30. 90 root 3 cos 30. Cos 30 is root 3 over 2. Root 3 over 2. Root 3 over 2. The answer is 135 Newton. No? Root 3 over 2. You missed this one. You need this one. Okay, I will explain that one. You want to explain how I simplify this one or how I get the components? Simplification or getting the components? Okay. Look at this one, Buddha. We have to resolve this one into two directions. No, one is into x direction, other one is into y direction. Look at this. You have to find this component and this component. You can if you cannot understand at one time, you can draw these two forces. Then you can easily see the forces. No, you can draw these two forces, x and y. You have to find x and y. X and y means this is the y, this is y, this is x. This is 50 times root 2. 50 times root 2 means the hypotenuse of this triangle. Therefore, x is equal to 50 root 2 times cos 30. Y is equal to 50 root 2 times sin 30. Because y is the opposite side. Y is the opposite side. It is the opposite side. This is the adjacent side. So opposite side is may come with the sin 30. Adjacent side is come with the cos 30. Did you understand?
So then here also we use trigonometry, no?
Yes. That's why I have proven these two components in our theory part. Okay. At the beginning of class, we have proven this thing using our trigonometry knowledge. Okay? We have apply our trigonometry knowledge and found the value of x and y. You can use these two directly. You can use these two directly. Okay. That means, look at this. If it is R, therefore, if you want to resolve this force into this direction, the resolving component is R cos theta. This component is R sin theta. This component is R sin theta. This is R cos theta. This is R sin theta. Okay. So if you are given this kind of force, you can directly use this equations. Okay, those are not the equations, but you can directly use this relationship. Okay, you can directly use this relationship. Okay, the component of this force into this angle, or the component adjacent to this theta angle is equal to R cos theta. The components opposite to this angle, Opposite to this angle. Opposite to this angle is equal to r sine theta. You can use this relationship directly. Okay. Then, if you want to resolve a force into certain directions, the first thing you have to determine the angle between the force and that direction and the particular direction. Okay. In here, I can find this angle. It is equal to 30. Therefore, if you resolve this 90 root 3, this force into x direction, that means this is the adjacent side to 30 angle. This is the adjacent side. So it should be cos 30. It should be cos 30. 90 root 3 cos 30. Cos 30 is root 3 over 2. Look at this. Look at this. I have determined this thing using my mind. Root 3 over 2. This is equal to root 3 over 2. Root 3 over 2. You have to divide 90 by 2. It is 45. Then root 3 into root 3. Root 3 into root 3 means 3. 3 times 45 means 135. 135. You have to do it within your mind. Don't write a single step in between these two. හරිද? එක ස්ටෙප් එකක්ම මෙතනින් හරිය ලියන්න එපා. තනි කර හිතෙන් කරන්න ඕනි. එහෙම නැත්නම් හිත හැදෙන්නේ නැහැ. හරි? හිත හැදෙන්නේ නැහැ කියන්නේ ඊට පස්සේ හිත හැදෙන්නේ නැහැ. හරි? Alright. Then look at this one. The x component is in this direction, Puta. Therefore, x component is in this direction. The y component is in downward direction. Therefore, y component is the opposite side. No, it is the opposite side. Therefore, it is the opposite side. Make it. So it can be written as sine theta. Therefore, 90 root 3 sine 30. Sine 30 is half, no? Sine 30 is half. Therefore, this one is equal 45 root 3 Newton. 45 root 3 Newton. Okay. හරිද? Okay. This one can be done using other angle also. No? This one can be done using other angle. Look at this. Look at this. I can use the other angle also. As this angle is 210, how much this angle? How much this angle? It is 60, no? It is 60, no? It is 60 degree. හරිද? This is 60 degree. So now you can resolve this force using this angle into this direction and this direction. If you resolve this 90 times root 3 into y direction, you will have y component in downward direction, no? The y component is in downward direction. Look at this. It is in downward direction, and that is equal to 90 root 3 cos 60. Cos 60. No? It is 90 root 3 cos 60, because if we want to find this component, this component is the adjacent component, adjacent side to 60. Adjacent side to 60. If you want to find adjacent side, definitely you should go with cos 60. මෙන්න මේ angle එකත් එක්ක ගැවිලා තියෙන side එක අනිවාර්යෙන් cos වෙනවා. Therefore, it is equal to 45 root 3 Newton, because cos 60 is half. Cos 60 is half. Therefore, you have to divide it by 2. Then x component should be the sine value of this one. That means 90 times root 3 sine 60. Sine 60. Sin 60 is root 3 over 2. Therefore, this is equal to 135 Newton. 135 Newton. We can use both. Okay. Everyone, I need your responses. Do you get my point? Thank you. Okay. Thank you, Mute. Okay. හරිද මේ ටික? Shall I erase this one? Shall I erase? Okay. Then I will give another examples. Okay. I will give another examples. Okay. Resolve this one. Resolve these components. First one. Resolve this into write the questions. Find the resolve components in x and y directions. In x and y directions. Okay. Resolve these components. Resolve these process. Okay. Tell me, what is this x component of this one? X component. This one. X and this one y. Okay. X and y. So x component is in this direction. If you resolve this x force into x direction, look at this. 45 angle is the adjacent angle, or adjacent angle, or x is the adjacent side to 45, therefore it should be cos. 60 times cos 45. Cos 45 means 1 over root 2. 1 over root 2 means 30 times root 3. This is 30 times root 2 Newton. Look at this. 60 times 45. Cos 45. Cos 45 means 1 over root 2 puta. 1 over root 2. Therefore, I can write it as 30 times 2. 60 can be written as 30 times 2 into 1 over root 2. So you can divide it by like this. You know 2 is the square of root 2. Therefore, this is equal to 30 times root 2. You should get that one within your mind, okay? Then y component. Y component is the upward direction. Is in the upward direction. That is also equal to 60 times 60 sine 45. Sine 45. Both are equal. Both are equal. Therefore, this is equal to 30 times root 2 Newton. 30 times root 2 Newton. Okay, very good. The second one. The second one, you have to find, you have to find the angle first. You have to find the angle first. As this is a 2 to 5, this angle is 45. This angle is 45. This angle is 45. Therefore, I can draw the y component here and the x component here. Look at this. Y component is into this angle. Therefore, it should be a cos component. So y component in downward direction is equal to 50 times root 2 cos 45. Cos 45 means 1 over root 2. Therefore, it is equal to 50 Newton. Root 2 to root 2 will be cancelled out. X component will be in this direction. Look at this. Therefore, it is equal to sine component of this angle. Sine component. Both are equal. 50 times root 2 sine 45. Sine 45. Sine 45 means 1 over root 2. 1 over root 2 means root 2 to root 2 will be cancelled out. Therefore, it is equal to 50 Newton. 50 Newton. This one. Again, you have to find the angle. This angle is 60. That angle is 60. Then you can resolve this one into x direction and y direction. X direction and y direction. Look at this. The component into x direction is the adjacent component to this angle. Therefore, it should be cos value. Component with the angle. It should be a cos value. Therefore, x into this direction should be equal 90 cos 60. 90 cos 60. Cos 60 is half. 90 into half means 45. It should be equal to 45. Then y is in downward direction. Y is in downward direction. It should be equal to the sine value of this one. As this is the cos value, other one is equal to sine value. 90 times sine 60. Sine 60 is root 3 over 2. Root 3 over 2. Therefore, 45 root 3. Here 45 times root 3 Newton. Okay. I need responses from everyone. Did you understand that one? May I tell you now? Okay. Okay, Puti. Now 10 past 20. No? The heavy side. And a punch into a lag gun. Into a lag karang. Api 10:30. ආය පාරක් එන්න 10:30 අපි පටන් ගන්නවා 10:30 පටන් ගන්න ගෙලින්ම අපි අර මේකේ ප්‍රැක්ටිකල් ඇප්ලිකේෂන්ස් ටිකක් තියෙනවා ප්‍රැක්ටිකල් ඇප්ලිකේෂන්ස් ටික කතා කරලා වෙක්ටර් සිස්ටම් එකක් කොහොමද රිසෝල්ව් කරන්නේ කියලා අපි කතා කරනවා හරිද හොඳයි එහෙනම් 10:30 වලට ආයෙසර කට්ටිය වෙන්න දැන් පුංචි ඉන්ට්‍රෝල් එකක් කරගන්න හරි හරි ඕකේ කට්ටිය ඉන්නව නේද okay shall we discuss some practical applications of resolving of vector okay practical applications කීපයක අපි questions ටික කතා කරමු මුලින් second question the figure shows a car traveling with velocity 20 ms minus 1 along an inclined road an angle of 30 degree with the horizontal find the horizontal and vertical components of the velocity okay shall we do this I will give you 5 minutes please start to do this the second question the second question of the tute there is a car traveling in an inclined surface this car is traveling on an inclined surface with 20 ms minus 1 speed the inclination is 30 degree to the horizontal the question is find the horizontal and vertical components of the velocity let's do it quickly okay have you done good shall we discuss look at this the velocity is in this upward direction along the inclined plane no along the inclined plane it is in the upward direction okay therefore the direction of velocity is in this direction this is the direction of velocity with 20 ms minus 1 this is the direction of velocity now I have to resolve this velocity into two components which is in one side one component is in horizontal other component is in vertical that means I have to resolve this velocity into x and y components as I told you earlier the first thing you should do you have to find the angle between this vector, between this vector and one of these components. You have to find the angle between the vector and the one of these components. The first thing you should do that one. Okay, you have to find the angle between one force, one component and the given force, given vector. How to find the angle here? How to find the angle here? Tell me. How to find the angle? According to the given data, this plane, this inclined plane, inclination that is equal to 30 degree with the horizontal. This is horizontal. So the inclination of the plane with the horizontal is 30. As this is the horizontal and as this is the horizontal line too, those two lines should be parallel to each other. No, these two lines should be parallel to each other. So as they are parallel to each other, this angle should be equal to how much? This angle should be equal to, tell me, give me answers. How much this angle? This angle? My angle is 30 degree.
30 degrees.
Yeah, what is the reason?
Corresponding
Yeah,
angles.
corresponding angles. Very good. Those are corresponding angles. Therefore, this one is 30 degree, Puta. Now I can resolve this one, no? Now I know the the angle and the original force. So x component is in this direction. It is equal to then 20 times cos 30. 20 times cos 30, because x means adjacent side to the 30. Adjacent side to the 30. Therefore, it is cos 30. Therefore, this is equal to 10 times root 3 meter per second. Meter per second. You have to write that one. This unit, okay? Because this is a velocity. No? Y. Y is in upper direction. Therefore, it should be equal to 20 times sin 30. Sin 30 is half. Half means this is equal to 10 ms minus 1. 10 ms minus 1. Those are the two components in horizontal and vertical directions of this velocity. Okay. Then the next question. Question number 3. Question number 3. Let's do it. Question number 3. The figure shows a mass of mass of mkg placed on an inclined plane, inclined at an angle theta degree to the horizontal. Find the components of resolution along the inclined plane. Look at these two directions. Along the inclined plane and perpendicular to the inclined plane. Those are the two perpendicular directions. Okay. Now it is not the horizontal and vertical. Now it is not the horizontal and vertical. What are the two perpendicular direction? along the plane, along the inclined plane and perpendicular to the inclined plane. Those are the two components. Okay. Look at this. Before doing that thing, I will ask the same question here. Okay. Look at this. Then you can go for that question. Okay. Okay. Now we have resolved this force, resolve this vector 20 ms minus 1 in horizontal and vertical directions. Now I'm asking to resolve this vector. In this case, we cannot do that because this is along the plane. Okay, go for that question. Yes, you have to use. Yes, that is the first thing. That is the first thing you have to know. In here, you are given weight, sorry, mass. You are given the mass. Mass is not a mass is not a vector. Mass is not a vector. So the first thing you have to find the vector. Vector here. The vector is mg. Okay, look at this. In here, we are given weight only. We are given the weight only. We are given the weight only. But now we have to find the force. In here, the force is, sorry, we are given the mass. Mass only, we have to find the weight. You know how to find the weight. Weight is equal to m into g, no? M into g. G means gravitational acceleration. I think you know this one in your orders, no? Weight. Weight එක කලනේ තියෙන ඔලවලද? කලනේ තියෙන ඔලවස් වලට weight එක. Okay. In here you have to use the weight, okay? Weight means the gravitational force into the downward direction, okay? Normally weight is in downward direction. Weight, every weight sign downward direction, puta. Therefore, the weight should be in downward direction. So you have to resolve this weight into two components. One is along with the inclined plane. Other one is perpendicular to the inclined plane. Those are the two components. How to resolve this one? As I told you earlier, there is only one method. If you want to resolve any force, then you should find the angle between the force and one component of the resolved component. Okay. Therefore, you have to find either this angle or this one. Anyone. The first thing you should do, finding angles. There is no x and y. There is no any x and y. Okay. There is no x and y, but we have to resolve this force. That means mg. We have to resolve this mg force along with the inclined plane and perpendicular to the inclined plane. Those are two components. These are two perpendicular components. Okay, shall I do? Suppose this one. This is the horizontal. This inclined plane has an inclination. Okay. This inclined plane has an inclination to the horizontal. Has an inclination theta to the horizontal. Okay. Now you should draw this one. Actually, I don't want to draw the box. Okay. It is not necessary drawing this box. It is not necessary. Or there is a force. Gravitational force. It is mg. Definitely, it is in vertical direction. It is a vertical force, no? Mg is a vertical force, so it is in vertically downward direction. As mg is a weight, it should be vertically downward direction. Okay. Then look at this. Now I have to resolve this force parallel to this plane. That means into this side, and as well as into this side, perpendicular to this side. Those are two components. Those are two components. Suppose this one P and this one Q. Now you have to find the angle. Once you determine this one, now you have to find the angle. Look at this, how to find the angle. You know, as this is the horizontal, and this is the vertical. Mg is the vertical line, no? Mg is a vertical line, this is the horizontal line. So this angle should be 90. So as this angle is 90, how much this angle? Give me the answer. Again. Yes, 90 minus theta, no? 90 minus theta. 90 minus theta, because this is theta, this is 90. This one should be 90 minus theta. 90 minus theta. Theta plus 90. Suppose this one alpha. This should be equal to 180, no? This should be equal to 180. Therefore, alpha should be equal to 90 minus theta. 90 minus theta. Therefore, you can sorry, you can use this one. Suppose one angle is 90, other angle is theta. One angle is 90, other one angle is theta. Therefore, the remaining angle should be 90 minus theta. 90 minus theta. Okay. Okay. As this angle is 90 minus theta, how much this angle? How much this angle? How much this angle? That angle? Huh? How much? Same. Reason? Reason? This is geometry. This is not physics. The reason?
Sir, can you repeat the question again?
Question is, Puta. The first thing. Did you understand this one? How I get the 90 minus theta? Because this is angle of triangle. No? Angle of triangle. This is 90 minus theta. This is 90 minus theta. So, if this is 90 minus theta, how much this angle? My question is, if this is 90 minus theta, how much this angle? This dotted one?
90 minus theta.
Yeah, what is the reason?
Vertically opposite angles.
Yeah, very good. Vertical opposite. Yes. This one is 90 minus theta. Look at this. P is a perpendicular force. P is the perpendicular force to the plane, inclined plane. Therefore, this angle is 90. Therefore, as this angle is theta, 90 minus theta, this one should be equal to theta. This one should be equal to theta, no? 90 minus theta plus 90 and plus theta is equal to 180. Therefore, this one should be theta. Theta plus 90 minus theta plus 90. Plus 90. How much? Theta will be cancelled out. It is 180. Therefore, these are the angles of triangle. These are the internal angles of a triangle. The addition should be 180. So this angle is 90 minus theta. This angle is 90. So that one is should be the theta. That one should be theta. That one should be theta. Okay. Now we find, no? Now question is solved. Because now I know the original force and the angle between the original force and one component. Therefore, definitely P is in this direction. In this direction. Direction perpendicular to the inclined plane. Look at this. Look at this mark. Perpendicular to the inclined plane. Perpendicular to the inclined plane. The direction of P. P is perpendicular to the inclined plane. That is equal to mg. Mg. That is equal to mg sin theta. And theta then. Look at this. There's mg theta. Theta here P. P is the adjacent side. No, P is the adjacent side to this angle. P is the adjacent side. And theta के पैත්තර තමයි मैं रिसोल्व करන්නේ. theta के पैත්තර रिसोल्व करන්නේ. theta के पैත්තර रिसोल्व කරනවා නම් අනිවාර්යෙන් cos value එක එන්නේ. අය adjacent side. It should be cos theta. Theta is P is the adjacent side to the cos to this angle. Therefore, P should be mg times cos theta. It is mg cos theta. Then Q is parallel to this angle, parallel to this inclined plane. It should be mg sin theta. Because theta belongs to this side. This side, that means P. So this should be cos theta, sin theta. Q should be sin theta. P should be cos theta. තේරෙනවද ඒක? මට ඕනේ හැමෝගෙම responses. තේරුණාද මේක ගත්ත හැටි? clear. Other ones? Respond නැහැ කියලා කියන්නේ clear නැහැ කියන එක. අනිත් අය කො Okay. You can draw this one. Then you can go for discussion.
So for the exam also, should we mark it on the diagram?
Sorry?
For the exam, should we mark all the details on the diagram?
Mark all the details means puta. You means all this one. MG.
Like 90 minus theta, like that.
Actually, once you actually, when you are sitting for the exam, you will do a lot of these kind of questions. Therefore, definitely you are not going to mark this one. You can remember this one. Okay. Once you remember this one, you are not going to mark. Okay. Until you remember, you can mark that one. Right? Then you don't want to mark. You don't want to mark. Right? Once you compare it with these angles, these geometrical values, then you will not you are actually you are not going to mark. Okay. තේරුමක් නැහැ ඒක ටයිම් එක වේස්ට් වෙන විතරයි වෙන්නේ. පාරක එලිමන්ට් ඇන්ගල් එක ගන්න පුළුවන් නම් ඇන්ගල් එක එලිම ගන්න. හරි. ඒකේ කිසිම ප්‍රශ්නයක් නැහැ. මොකද මෙතන ජියොමෙට්‍රි අහන්නේ නැහැ. ආ කොහොමද ගත්තේ කියලා අහන්නෙත් නැහැ. හරිද? මේ ඇන්ගල් එක එහා පැත්තේ එකකින් බලන් ගත්තත් දන්නේ නැහැ කවුරු. හරි. අපි ඇන්ගල් එක විතරයි මොන්නේ. ඇන්ගල් එක විතරයි මොන්නේ. මේක ජියොමෙට්‍රිකල් නොලෙජ් එකක් බලන්න නැහැ. හැබැයි ඔයාට ඇන්ගල් එක ඔළුවට යනකම් මේක මාක් කරා කියලා ප්‍රශ්නයක් නැහැ. හරි. මම මේක මෙහෙම යන්දෙත් ඉතින් මේ ඕගලන්ට ඔළුවට යන්න. එහෙම නැත්නම් මේ ක්වෙස්චන්ස් කරනකොට මේ මෙතනින් එහාට අඳින්නේ නැහැ. මෙතනින් එහාට මෙතනින්ම mg sin theta mg cos theta කියලා දානවා එච්චරයි. හරි. ඒක ඕගොල්ලෝ දැන් ওই නිව්ටන්ස් වලින් ක්වෙස්චන්ස් කරනකොට අනිවාර්යෙන්ම ඕගොල්ලොත් ඔක් කරන බයන් දෙයක් නැහැ ඕගොල්ලොත් ඔක් කරන. හරි. මේක ඕගොල්ලන්ගේ පළවෙනි ක්වෙස්චන් එක නිසා තමයි ඕගොල්ලන්ට ඔය මේ දාන්න ඕනද නැද්ද කියලා හිතෙන්නේ. ඉස්සරහට ඕගොල්ලෝ දාන්නේ නැහැ. හරි. Okay. So I think it is better to mark the angles until you remember that one, until you have a confidence with those geometrical values, then go without angles, go without marking anything. Okay. Okay, let's do the fourth question and fifth question. Fourth and fifth questions. Okay. Shall we do fourth question and fifth question? Yeah, parallel 10. All right, very good. Fourth question. Now 20 kg, no? 20 kg here, no? I'm not going to do fourth question again because the same diagram here. Same diagram here. Only thing is weight or mass. I have to apply. I have to write this as 20 kg. 20 kg. Therefore, the same thing here. Same thing here. 20 times G. 20 times G means how much? G means normally we can take G as 10, no? I think you know this one. Therefore, this is equal. Angle is 30, no? Angle is 30, no? This is equal. Mg means 20 times 10 into cos 30. Cos 30 means root 3 over 2. Root 3 over 2. Okay. So fourth question, exactly same question as the third one. Therefore, I am not going to do it again. The only thing is I can substitute the value for M. So here 10. So you will have 100 times root 3 Newton. Okay, this is Newton. This is Newton. As this is a force, please keep it as Newton. Okay, don't write it as a kg. Kg is a weight. Mass mass is not a vector. It is a scalar quantity. Therefore, don't write it as a mass. Then again, mg is now 20 times G means 10. Sin 30. Here theta is 30, no? Here theta is 30. Theta is equal 30. In fourth question, that means this is half. Therefore, this one is equal to 100 Newton. 100 Newton. Okay. Why? I have explained the thing. This is not the equation, Sudha. Actually, look at this. Those are not the equations, but look at the third question and fourth question. Okay, I will explain. Look at the third question and fourth question. Both are same. Both are same. The only thing is, in fourth questions, there are values, numerical values for m and theta. M and theta, that's only. Okay. I will explain it again. Okay. බලන්න හොඳට බලන්න මේ third question එක මේ මම ඒක හැම වෙලෙම හොඳට අහගන්න. හොඳට අහගෙන ඉන්න මම ඒක හැම වෙලෙම අර එවල අහන්න. Third question මේ third question එක මම ඉස්සරහ explain කරන්නේ. Okay. Let's do it again. Here you can see now here there is a weight. There is a weight into the downward direction. No, there is a weight into the downward direction. Now you are asked to resolve that weight in parallel to this plane and perpendicular to this plane. Those are the two directions that you need to resolve this force. Okay. So you have to resolve this force mg into the direction P and into the direction Q. As I told you earlier, if you want to resolve a force or vector, then definitely you have to do one thing. What is that? You have to find the angle between the particular force and one component. Okay, in between, you have to find the angle in between one component and the given force. So you can find either this angle or this angle. It is not necessary. It is not a compulsory thing to find this angle. You have to find either angle. Okay. You know this. Now you know this. You know this force. This mg. No. Now you have to find this angle. That's why I asked you to use your geometrical knowledge. No. As this is theta, this one is 90 minus theta. So this one is 90 minus theta because they are vertically opposite angles. Then look at this. As this component perpendicular to the plane, this angle is 90. This angle is 90. Therefore, this angle should be theta. Now you have found the angle between one component and the original force. Now you can resolve this one, no? If you resolve this force into p direction, that should be p cos theta, because p means the adjacent side to this theta. P means the adjacent side, no? මේත් එක බැඳිලා තියෙන කොහොමද මේ θ ගේ පැත්තට තියෙන θ ගේ පැත්තට තියෙන component එක අනිවාර්යෙන් cos වෙනවා. It should be cos theta because p is the adjacent side to theta. Q is this side, no? That means opposite side. So Q is opposite side. Therefore, Q means mg sin theta. තේරුණාද? Fourth one is same question. I have to replace mg m using 20. G means 10. Theta is 30. තේරුණාද පුතේ? It's true. තේරුණාද? mg means put a force, no? Here we are given mass. Here we are given mass. I will explain. Okay, I will explain it again. Okay. Here we are given mass, no, puta. So we are given mass, but we are asked to find. Look at this. Find the components of weight. මෙතන weight කියලා වැටලා නැහැ. ඒක හැබැයි මම ඒක දාලා දෙවන්න. Find the components of resolution of weight along the inclined plane and perpendicular to the inclined plane. හරිද? weight එක හොඳේ. weight එක කියලා දාගන්න එක. හරිද? නැත්නම් මොකද්ද කියලා දීලා නැහැ. හරි. නමුත් අපි මෙතන ගන්න ඕනේ weight එක මොකද normally we have to use a vector, no? Mass is not a vector, so vector of so we have to find the vector. Okay, there's a missing word in the question. You have to resolve the weight. That should be corrected. You have to resolve the weight of this object. Okay, you have to resolve the weight of this object. Now you are given mass. If you are given mass, how to find the weight? Weight means the attraction force between the object and the earth. Attraction force between object and the earth. The attraction force between an object and the earth is called as the weight of this object. So weight can be determined using F equal ma. Here F means mass, A means gravitational acceleration. So that is called as G. That's why the weight is equal to mg. Weight is a force. Mass is a scalar. Okay, mass is a scale. Weight is a force. I think this one I think all element කරන්නේ තියෙන්නේ. මම ඒකයි මේ දන්නේ. මේ weight එක weight කියන්නේ මොකද්ද කියන්නේ? concept of weight. All color anything. Okay. Look at this is the concept of weight, Puta. Weight is the attraction force. Look at the weight is the attraction force between a mass and the earth. Mass and the earth. So force can be determined by Newton's second law. If we call ma, so here mass is m. M is gravitational acceleration. It is equal to gravitational acceleration. So because if I drop my object freely, it goes under a gravitational acceleration. It goes under the gravitational acceleration. Therefore, the acceleration is equal to gravitational acceleration. That's why the weight is equal to mg. Okay? Did you understand? තේරුණාද?
Okay, sir. Thank you.
Okay. That's why I use mg. Sorry, there is a missing word here. Puta. You have to resolve the weight. Okay, you have to resolve the weight. I will correct that thing. Okay, I will correct. Find the components of resolution of weight of this object along the inclined plane and the perpendicular to the inclined plane. Right? Okay, fifth one and sixth one. Fifth and sixth one. Tag gala karan. Pi hai. Okay. Tell me the answer for question number 5. Question number 5. Question number 5. Question number 5. The figure shows a simple pendulum of mass m hanging from the roof of a moving train. It is inclined at an angle theta to the vertical. Find the horizontal and vertical resolution components of tension force T, which is mentioned in the figure. You have to resolve this tension force. Answers මොනවද? What are the answers of for question number 5? Hmm? මේක answer එක මොකද්ද? So, there is a simple pendulum. Here. This angle is theta. This angle is theta. This force, the tension force is T. You have to resolve this tension force into horizontal and vertical direction. You have to resolve this one in horizontal and vertical direction. Horizontal and vertical direction. Right. If you want to resolve the tension force, what should you do? Tell me. You have to follow the same process, Buta. You have to follow the same process. What is the process? Tell me how to resolve tension force. How to resolve this tension force? How tension force to resolve current? How to resolve this one? Tell me. You have to follow the same procedure. Procedure follow කරන්න. So how to follow what is the procedure? මොකද procedure? The first thing you should determine the angle. Okay. The first thing the first thing you have to determine the directions. What are the directions of two components? That is the first thing. Okay. You have to determine determine the components, directions of two components. Okay. In here, you are asked to resolve this force. You are asked to resolve this force in horizontal and vertical directions. Horizontal and vertical directions. Okay. The first thing you have to determine what are the directions of two components. That is the procedure. The first thing you have to determine what are the directions of two components. They are horizontal and vertical components. You have to mark that one. Once you mark that one, apply the second process. What is the second process? What is the second method? Second steps. What is the second step? Once you mark the directions of two components, then you have to determine the angle between the original force and one of these components. You have to determine the angle in between the original force and one of these components. It can be either this force or this force. Okay. Do you understand these steps? Tell me. What among them answers only? Do you understood that one? Do you understand? Very good. Others? නැද්ද? Respond නැතුව කට්ටියක් කියනවා. හරි. Good. හොඳයි. Those are the two steps that you should follow. Okay. So what is the first step? The first step is you have to determine the directions. Normally, they are given in the questions. They are given in the questions, or you have to determine that directions. Once you determine directions of two components, mark that one. Okay. Those are two directions. Then the second step is to resolve this force into these two directions. You should know the angle. The second step is you have to find the angle in between this original force and one of those two components. So what is the easiest angle to find here? Angle between XO, angle between T and Y. Angle between T and XO, angle between T and Y. දෙකම ලේසිනේ. දෙකම ලේසිනේ. ආමර කියන්න බලන්න. I will ask. Okay. The first question. I will ask from Stu. Stu, tell me. What is the angle between T and X? T and X. What is the angle between T and X? What is the angle between T and X?
90 minus theta.
Very good, Puta. 90 minus theta. Then okay. Malmi, okay. What is the angle, Malmi? You have to tell me. What is the angle between T and Y? T and Y. What is the angle? T and Y. T and Y. T and Y. What is the angle between T and Y? T and Y. Hiruni, what is the angle between T and Y?
Theta?
Yes, theta. It is theta. Very good. It is theta. It is theta. This one 90 minus theta, Puta. This one 90 minus theta. You can use either way. Okay? You can use either way. If you use theta, then you can use that angle. Or if you want to use 90 minus theta, you can use 90 minus theta. Okay? Shall we do it? Do this thing both ways. Okay? Okay. The first thing, I will use theta. I will use theta. Okay. Now theta is in between y and t. No? Theta is in between y and t. Therefore, y should be the cos value of theta. No? Y should be the cos value of theta because y is the adjacent side to theta. Therefore, y should be the cos value of t. Cos value of t. Cos value. Therefore, y should be t cos theta into the upward direction. Then x should be the sine value of theta. T sine theta. That is the first method. Then the second method. Second method. I can use 90 minus theta instead of theta. I can use 90 minus theta instead of theta. If I use 90 minus theta, look at this. Now x is the adjacent side to this theta, no? X is the adjacent side to this theta. X is the theta in between t and x. So x is the adjacent side to the theta. Therefore, x can be written as t cos That should be cos value. Cos 90 minus theta. It should be cos 90 minus theta. Now you know the trigonometry, no? 90 minus theta. Cos 90 minus theta should be equal to sin theta. Sin theta. As this is the odd multiplication of 90, cos will be changed as sin. Therefore, x is equal to t sin theta, because cos 90 minus theta is equal to sin theta. Hari. There's no change. You can use either angle. The result is same. Okay. And the second method, the upward force, y should be t sin. This is cos theta, no? Therefore, upward force should be equal to sin, no? Sin 90 minus theta. Again, sin 90 minus theta, as is in 90 minus theta, it should be equal to cos theta. It should be equal to cos theta. Therefore, y component is equal to cos theta. Did you get my point? Everyone, I need responses. Did you get my point? Both ways. Thank you. Others? Okay, Bhuti. Okay. Sorry. Therefore, this is the answer for question number 5. Right? Question number 6. Question number 6. Question number no. Question number 6 I will explain it in next week. Okay. I will do the next part. Okay. Do you have any questions up to now? Do you have any questions up to now? Because we have done actually in these type of questions, we discuss regarding the resolutions of one singular force. Okay, we have resolved one force here, no? In all these questions, we have resolved only one force. Only one force. Therefore, these kind of questions are based on resolving one singular force. මට තේරුන්නේ නැහැ පුතේ මොකද්ද මේ මේ මෙතඩ් එක නැත්නම් මේකද වක්න්නේ මේ තීර එකද ඒකත් පුළුවන් හැබැයි මෙහෙමයි නැගේ ඔයාලට මේකත් යූස් කරන්න පුළුවන් මම ඒක යූස් කරේ නැත්තේ මේක තව මේ ඒක යූස් කරන්න ගියොත් එහෙම මැකනික්ස් පාර්ට් එකක් කියා දෙන්න වෙනවා මේ මේක යූස් කරන්න පුළුවන් මොකද දැන් මෙතන තීටා මෙතන t නම් මෙතන t තියෙන්නේ අනිත් පැත්තට as this is a string the tension force acting on this point is on this side, therefore you can use this angle also, but the thing is I cannot explain that thing because it is a mechanics part. Okay, mechanics part එක මට දැන් explain කරන්න බෑ mechanics කරනවා නම් explain කරන්න එක හැබැයි එහෙම කරන්නත් බෑ මොකද මෙතන අහලා තියෙන්නේ පුතේ ඔයාලට resolve කරන්න කියලා මෙන්න මේ force එක. Okay, you are asked to resolve this force is acting on this object. This force is acting on this object. So if we use this angle belongs to this T force. This angle belongs to this T force, and this T is not acting on this object. Okay, it is not acting on this object. Therefore, you may have the same result. You may have the same result, but the thing is, two forces are acting on different objects. This is acting on this point, and this T is acting on this object. Okay, That is the difference between two forces. Okay, you may have same result. Okay, that is okay, but the thing is you are asked to resolve the tension force acting on this object. ඒකයි මම එක tension force එකක් විතරක් මාක් කරේ මේ ෆිගර් එකේ නැත්නම් tension force දෙකක් මාක් කරන මට ඔක අර මැකින්ස් පාර්ට් එක කියා දෙන්න වෙනවා එහෙමත් එම ළමයිට තේරෙන්නේ නැති වෙනවා දැන් මම හරි did you understand okay 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 all these questions are based on resolution of one single force single force. Okay, actually we have resolved only one force here. Now we are going to resolve more than one force. More than one force means a vector system. Now we are going to resolve a vector system. How to resolve a vector system? How to resolve a vector system? That is the second one. That is the next step. Okay. Write a topic. Write a topic. Write a topic. Resolving a vector system. Resolving a vector system. Resolving a vector system. Okay. You can draw this figure with me, okay? Theta 1, theta 2. This is theta 4. This is theta 4. F5. F6. This is theta 6. Theta 6. Okay, write this image figure. Draw this figure. Okay, look at this one. Suppose we are given this kind of vector system. There are a lot of vectors, yeah. But all the vectors are acting on the same point. Okay, that is the most important thing. All are acting at the same point. Now we have to resolve this vector system. This is a huge number of vector system. Okay, but I will explain that one in using two vector system. So not three vector system. Okay. Suppose you are given this kind of two vectors, f1, theta 1, and f2. This is theta 2. Suppose you are given two vectors and you are asked to resolve these two vectors into x and y directions. What is your objective? You are given two vectors. This is the two vectors, and you are asked to resolve these two vectors in x and y directions. How to do that? Definitely, you should resolve these two vectors separately. Buddha. The first thing, you have to resolve f1 first. Then you have to resolve f2. You have to resolve one by one. You have to resolve these two vectors one by one. If you are resolve f1, you will have x component in this direction, no? That is x component of f1. X component of f1 is in this direction. It is equal f1. Look at this. f1 cos theta 1, no? Cos theta 1. This is the x component of f1. f1 cos theta 1. Then look at this again. Then what is the y component of f1? Y component of f1 is in upward direction. It is equal f1 sin theta 1. f1 sin theta 1. Look at this. X component is in between theta and f. That means this is the adjacent side. This is the adjacent side. Therefore, it should be cos value. Therefore, it should be cos value. Okay. So this is the resolved component of f1 force. Then you have to resolve f2. If you resolve f2, look at this. If you resolve f2, the x component is in left hand side. No, it's in this direction, not in the right hand side, but it is in left hand side. It is into left hand side. So the x component of f2 is in left hand side. Therefore, x component of f2 is opposite to this one, and it is equal f2 cos theta 2. f2 cos theta 2. And what is the y component of f2? What is the y component of f2? Y component of f2 is in upward direction. That is equal to f2 sin theta 2. Okay. Did you get this one? Make it everyone. I need responses from everyone. නැතමං අහනවා හැමෝගෙම. තේරුණාද? මේ කරපු දේ තේරුණාද? No. Thank you. තේරුණාද? Steve?
So can you explain the last bit again?
That means this one. Look
No,
at
from the other side, sir.
this
The
one.
first one, yeah.
Look at this. F1. Then now you are given two forces to put. Now you are given two forces to resolve. If you are given two forces to resolve, you have to resolve those two forces separately. First thing you have to resolve F1. Then you have to resolve F2. The red color one is resolved component of F1. You have to resolve F1. If you want to resolve F1, look at this. X component is in this direction, into the right hand direction. That component should be equal to F1 cos theta 1 because X, the theta 1 is in between X and F1. Therefore, X කියලා කියන්නේ මෙයාගේ අර X component එක කියලා කියන්නේ theta 1 තියෙන පැත්තේ තියෙන component එකනේ. Therefore, this is a adjacent angle, adjacent side. Therefore, that should be equal to cos theta 1. So, y side is in upward direction. That should be equal to sin theta 1. Sin theta 1. Because it is the opposite side. Y component is the opposite side. So, then again, blue color one. Blue color one means F2. Components of F2. Now, if you resolve this F2, look at this. You have to, you have to bend this force to this direction. If you bend this force into this direction, look at this. That should be F2 cos theta 2 because if you bend this force into this direction, the angle is in between this. Angle. If you bend this force into this direction, cos theta 2, F2 cos theta 2, then you have to bend this force into y direction. If you bend this force into y direction, there's no angle here. That means it should be sin theta 2. It should be sin theta 2. එහෙම මතක තියාගන්න පුළුවන්. හරිද? මේ පැත්තට බෙන්ඩ් කරන්න මේ පැත්තට බෙන්ඩ් කරනකොට මේ ඇන්ගල් එක හම්බ වෙනවා මේ. ඇන්ගල් එක හම්බ වෙනවා නම් අනිවාර්යෙන් මේ පැත්ත cos. මේ පැත්තට බෙන්ඩ් කරන්න. ඇන්ගල් එක හම්බ වෙන්නේ නැහැ. එහෙනම් sin. මෙයා මේ පැත්තට බෙන්ඩ් කරන්න. මේ පැත්තට බෙන්ඩ් කරනකොට ඇන්ගල් එක හම්බ වෙනවා. එහෙනම් cos. මේ පැත්තට බෙන්ඩ් කරනකොට ඇන්ගල් එකක් නැහැ. එහෙනම් sin. හැබැයි එහෙම මතක තියාගන්න එපා. මතක තියාගත්ත ගමන් නැහැ. එහෙම තේරුම් ගන්න යන්න එපා. තේරුම් ගන්නකොට දැන් ගෙදර ගිහලා මුලින්ම කරන්න ඕනේ දේ අර කියා දීපු දේ හොඳට තේරුම් ගන්න. මම මුලින් අර රෙකෝඩින් එක බලලා තේරුම් ගන්න. රෙකෝඩින් එක බලලා තේරුම් ගන්න මොකද්ද කිව්වේ කියලා. හරි? Those are two components of x and y. හරි. හරි. Look at this. Now there are two components. Now there are two components into the x direction and as well as there are two components in the y direction. So if you want to find the resultant components into the x direction, you have to take the resultant force of these two vectors. Suppose you need to find the x component, total x component into the right hand direction. Into right hand direction, then you have to add these two forces. You have to add these two forces. As they are two parallel forces, you can simply add these two forces, no? මේ දෙන්නම x පැත්තට ඉන්නේ එහෙනම් ටක් ගාලා ඔයාලට මෙයාලගේ numerical values ටික add කරන්න පුළුවන්. But when you add these two forces, you have to consider directions too. If you want to add the forces into this direction, that means forces into this direction are positive and forces into other directions are negative. Therefore, the total force into the right hand side is equal to F1 cos theta 1 minus F2 cos theta 2. Why because this is minus because X F2 is in left is into left hand direction. It is not into right hand direction. So if I
Excuse me,
want
sir.
to, oh, sir, oh, sir.
So here we take the negative value according to the direction, na then.
Yeah, direction is,
In the opposite direction, we take it as negative, na?
yeah. Actually, now there are two forces. No, one force is here, X F2. Other force is into this direction, X F1. Now you are asked to find the total force into this direction. If you want to find total force into this direction, you have to add these two forces. If you want to add these two forces, you have to consider the magnitude as well as the direction. Therefore, forces into these directions are positive. Forces into other opposite directions are negative. Everyone, I need your responses. Did you get my point?
Yes, sir.
Okay, thank you. The same thing you have to do here. You have to take the resultant y component. You have to take the resultant y component. The resultant y component in upper direction. Then you should add these two forces. These two forces. Fortunately, these two forces are in upper direction. Therefore, this is F1 sine theta 1 plus F2 sine theta 2. 2 sine theta 2. Okay, so this is the resultant x component of this vector system, and this is the resultant y component of this vector system. So how to find the resultant components of a vector system? Then you should follow this method. What is the method? You should resolve. Listen very carefully. You should resolve each and every vector separately. Okay. Once you resolve each and every vector separately, then you have to find the resultant force into x direction and resultant force into y direction. Okay. You know how to find the resultant force. Neither. Resultant force එකක් වань දන්නවනේ. Resultant force එකක් කොහොමද හොයන්නේ? Vectors එක add කරන්න. That is a simple way. No? You have to find the resultant force in this x direction and resultant force in y direction. In our previous lesson, we have done how to find the resultant force. No? In this case, all are in one direction, all are parallel to each one. Therefore, you can simply add and subtract. Okay. If any forces are in same direction, the resultant is the addition of those two forces. If there are two forces in opposite direction, the resultant is equal to P minus Q, no? P minus Q. මතකද අපි කරපුවා? හරි. Okay. මේකත් වැදගත්නේ. නමුත් මම මේකෙන් දෙන්න නැත්තම් වෙලා යනවා. මේව දාගන්නකෝ. මේව දාගන්න. Okay, write this paragraph. In this case, we have to follow the following method. We have to follow the below methods.
So in this way,
In this case, we have to follow the below methods. Number one. The first step. First step. Resolve each and every vectors separately. Each and every vectors separately in x and y directions. Second one, find the resultant vector. Find the resultant vector find the resultant vectors find the resultant vectors in x and y components separately.
Sir, can you repeat the second one again?
Find the resultant vectors in x and y directions separately. Right under that point. Once we find the resultant x component and the resultant y component, the resultant x component and the resultant y component, the vector system is converted to perpendicular components. බලන්න මේක ආයෙසර. බලන්න පුතේ මේක ආයෙ පාර. මේ මෙතන ඇත්තටම අපේ මේ රිසෝල්ව් කරනවා කියලා කියන්නේ මොකද්ද? ඇත්තටම රිසෝල්ව් කරනවා කියලා කියන්නේ වෙක්ටර් සිස්ටම් එක අපි වෙක්ටර්ස් දෙකකට අපි මේ ඕව කර ගන්නවා කියන එකනේ. දැන් මෙතන අපි කලින් නම් තනි වෙක්ටර් එකක් නම් තිබ්බේ අපිට වෙක්ටර් දෙකකට කෙලිම කරන්න පුළුවන්. නමුත් දැන් මෙතන වෙක්ටර් සිස්ටම් එකක් තියෙන නිසා මට එකපාර වෙක්ටර්ස් දෙකක් එන්නේ දෙකකට වඩා වැඩි ගාණක් එනවානේ. මේ මේකව මේ පැත්තට රිසෝල්ව් කරොත් එම මෙතන මේ මෙන්න මේ xf1 කියලා ෆෝස් එක එනවා. මේකව රිසෝල්ව් කරොත් මේ ෆෝස් එක එනවා. එතකොට x ඩිරෙක්ෂන් එකට ෆෝසස් දෙකක් තියෙනවා. y ඩිරෙක්ෂන් එකත් ෆෝසස් දෙකක් තියෙනවා. එහෙම බලන් ගියා මේක රිසෝල්ව් වෙලා ඉවර වුණාට පස්සේ අතන ෆෝසස් හතරක් ඇවිල්ලා. දෙකක් වෙනකොට. එහෙනම් මම ආය පාරක් මේව දෙකක් කරගන්න. එහෙනම් මම කරගන්න ඕනේ මෙයාගේ x පැත්තට තියෙන resultant component එක ගන්නවා y පැත්තට තියෙන resultant component එක ගන්නවා. එතකොට මෙන්න මේ දෙක resultant components ගත්තට පස්සේ මුළු vector system එකම ආය පාරක් vectors දෙකකට resolve වෙලා තියෙනවා. Okay. Actually we have to find the two components. We have to find two components, two perpendicular components of this system. Okay. That's why we have to get the resultant resultant x component and the resultant y component. Once you get the resultant x component, there is only one force into x direction. Once you get the resultant y component, there is only one component in the y direction. Okay. Okay. මේක අද ගන්නවා. හරි පුතේ. Okay, tell me. Today we have done resolution of vectors, resolution of two vectors. Under that topic, we have discussed how to resolve a vector into two perpendicular components. Then we have discussed how to resolve a single vector, into two perpendicular components. Then we have done some practical applications. Especially they will be used in our future questions in mechanics. Okay. Then after that, we have started to discuss how to resolve a vector system. Into two perpendicular components. In that case, when we are resolving a vector system, there will be more than one forces in x direction and y direction. Therefore, if we want to resolve this vector system into two perpendicular components, definitely we have to get the resultant x component and the resultant y component. Therefore, once you resolve these vectors separately, then you have to get the resultant x component and the y component. Once you get the resultant x component, the resultant y component, then the vector system will be converted into two perpendicular components. So that is the way of finding wait. Okay. Can you hear me, Puti? Okay. Okay. I need your responses. Up to now, do you have any question, things to ask? Hmm? Do you have anything to ask up to this level? Because now we are going to finish today's lesson. Therefore, if you need any clarifications, please let me know. Did you understand? Did you get my points up to this level? Respond lazy.
Understood, sir.
Okay, Pute. Then we can complete today's class, Puta. Everyone, if you want to go through the recordings, please go through the recordings before doing anything. That means if you want to do some questions or if you want to do some tutorials, then before that, please go through the recordings. I think it is better. Okay. Then
Sir, tomorrow we will be having
Can you hear me? There's a problem with my Zoom. Can you hear me, Puta?